So these are the outlines we'll be covering in this session. We'll first understand how important API is for cloud and what are the key factors, like all the stakeholders, user, developers, everyone mostly consider, and about the RESTful APIs, why they are best, and some overviews, and then some advanced tooling we'll be covering, and then some of the best practice we can take care. So myself, Ghanshyam Man, I'm an open source developer in NEC. I joined OpenStack in 2012 as a deployer and user of OpenStack. And then since 2014, I am doing the upstream development, mainly in Nova and OpenStack QA. You can reach me out on these social things.
I am Kenichi Omichi from NEC, and I am a principal software engineer in NEC. And I also upstream developer since 2012. Now I am a co-developer of QA and Nova projects.
Yeah, thank you. So let's start with the importance of the API for cloud. Because it's important to understand, means I can say my cloud is there, it has a lot of features, it has the stable features, and API is just the interface, it should be okay, means can be anything, we don't need to concentrate much on APIs. But that's not true, it's an integral part of the cloud ecosystem, and we'll be covering two aspects for this. One is the business and the technical aspect. So from technical point of view, it's oxygen for cloud services. Like that's the way external world communicate with your cloud. And they are the connection points for everything in cloud. Like if someone is developing an application or even some other services want to communicate with your cloud. So this is the way they communicate into your cloud. Like if, for example, OpenStack, Kubernetes, and OpenFV. So they have the different things. So they want to integrate as a complete solution. So API is the thing which allows them to communicate with each other. And API can be understood as technical facilitator for the cloud. Like it can disturb the services if your API is not good, like if it is easy to misuse, so it can disturb your cloud services, and it can like make a lot of noise on that. And it connects the business and technical interest. So APIs are like born out of business need, and the API strategy is implemented when API design and strategy need and align with overall business plan and products. Like when we design any cloud, so market people, salesperson, or the business people, they go in market and they check, okay, this thing people want. And important factor is, this is the way they want this product to use. Like, so from there it born up like, then what should be our API is, what best API design it can be. And then our technical things comes up, what all the best practice tooling we can use in that. From business perspective, APIs we can consider as a product. It's, as I said, it's not just like a calling interface to your product. API itself is a product. So you should design, you should sell, and you should use this API as a product. It enables it enables the DevOps automation. So you can build a lot of tools over the APIs who can automate your DevOps operations. It enables the business continuity and disaster recovery. So disaster recovery is one of the key factors for your cloud. So with APIs, you can like develop tool or any tool, existing tool, they call the APIs on your cloud, and they recover your system easily. A simple example is for OpenStack case, I have the like 1,000 of VMs. I just keep taking the backup of those, and when I recover, if APIs are very well stable, easy to use, hard to use incorrectly, so those things are very much easily possible to recover the complete solution and provide the things to the user as it is. So it plays very important role in disaster recoveries. It enables the operational efficiency. So like on cloud, even DR or any normal operations, we have to do a lot of operations over the services. And if humans does all the operation, even those operations are very well documented. Every day it is repeatable. It's easy to easy for humans to do the errors. So if you have toolings over the APIs, so it makes your all the operation very efficiently, it can be handled. Sorry. Yeah, next let's see the key factors in APIs. Like API is not just the developer thing, not just the user thing, or not just the operator things. There are like all these stakeholders, what actually their requirement, how they consider the key factor. So first one, no doubt the documentation. So the complete and accurate documentation is the most important factor in APIs. Because if there is a wrong documentation, that can lead and confuse about the API contract. Because if I have something on the API documentation, my code or my cloud is returning something else, I'll say, no, this is the contract, or this document is the contract. So it creates the confusion. So the accurate documentation as per how your cloud service is behaving is a very important thing. There was a survey, very old one, I think, though. The documentation was one of the most important factor out of the API design where all people consider. So this is very important to document your API correctly. I don't know if any of the APIs have the correct and complete documentation. So that's a very open and question on those, but this is the important factor, there is no doubt. So next things comes up like API versioning. It's important because it's hard to implement a perfect APIs always at the first time. So you guys keep doing the improvement based on the like user need, operator needs, or developer keep improving improving the features. They keep implementing the new feature and they want to introduce via the APIs. So versioning plays a very important role for the interop, backward compatibility, and easy to understand, okay, this was the one set, I use it, there is no change. This is the next set with this version. If I switch it, I get these kind of things. So it's very important. And easy to use correctly. Yes, it should not be so much complex to understand and how to use this API, and hard to misuse. This is one of the key points. If you can make this point completely 100% in your API, half of the problem is solved. If if API is difficult to use incorrectly, that makes the ideal APIs. It means it can solve a lot of things who can disturb your services, disturb your solution, product. And another factor, error code and message, it should be self-explanatory. Because it's obvious, like it's a software only, nothing else, or just some hardware. So errors are obvious things, error will come. So how easily and how correctly I can explain those error code and error message, and based on that, the user or operator or admin, they can correct those error, they can fix those error. That is the key point for APIs. If something error occurs, I don't give much information in error message, they'll be confusing what to do, and just like they'll be contacting cloud provider, your cloud is not good and all. So these are the things can be solved if you have the good error message and all. And yes, it should follow the standard guidelines. It's not like every cloud has their different standards for APIs. It becomes inconsistent for the usage. Yeah, this is the slide like I pasted from REST API Design Manifesto. I like, this is the most thing, like it has level -10 to 10. So -10 like the worst one and the 10 is the best one. Say 10th best one is, it is impossible to get wrong. If you can achieve it, that is the best thing you can do in your API. And the wrong, like worst thing, -10, if you see, it is impossible to get right. So if you can't make your API who can behave correctly, so that's the worst thing, like the product is not usable then. So now let's see how RESTful API is best suited for the cloud, why these standards or this REST is the key thing for your cloud APIs. One is scalability. Not necessarily its performance, but rather how easy it is for REST APIs to adopt and grow or plug in into the other system, because clouds, your solution is always should be scalable. Like your APIs should be scalable enough. Security, one of the key factor for cloud providers, they want their APIs very secure. For example, they don't want any user to have a permission to disturb their system, to restart their host or product. Like they should have a security things. Cacheability, obviously reduce the redundancy, latency things, and how much caching things you can do, how fast you can behave in your APIs. Then HTTP methods, being able to use HTTP method to manage the resources makes the REST APIs easy to plug into the other applications. So all of the applications, if they know, okay, these are the REST method, get, set, post, put, and patch. So these are consistent, and it makes easy for each developers to develop the application over that and even other toolings. Code on demand, they can temporarily like extend and customize the functionality of a client by like transferring the executable code. Efficiency, so REST API can use the smaller message format. For example, even if you use the JSON one, so it's very clear and smaller message format. It makes it efficient. And standardization, it uses the standard status code, error code, which solve half of the problem. So these are the factors like REST API is best suited for your cloud APIs. So let's cover a fast overview of what the REST API is. Sorry. So the REST representational state transfer, it was introduced and defined in 2000 by Roy Fielding, as most of them might know. And REST is an approach to communicate that is often used in development of web services. So it's mainly has a 6 constraint. It has the user uniform interface, stateless. It has the caching thing, client server architecture, layered system things, code on demand. It has so the standards are based on these 6 constraints, so that you can provide a consistent and a standard communication between the web services. What is RESTful APIs? So when web services use the REST architecture, they are called RESTful APIs or simple REST APIs. So they have like decoupled architecture, scalability, lightweight communication. And for cloud-based APIs, that's why the REST becomes popular for them. And OpenStack, Amazon, Microsoft, Google, all they have the REST APIs. And let's cover the HTTP methods. First, you have the post. If you want to create the resources, you can use the post, and this is the example like request and response. I'll not go into the much detail on this, just how the HTTP methods are. And then you have the get method to retrieve the representation of your resources, what is like all things on your resource it has. And you have the put method to update, replace the resources. You can use it like this. You can have the delete if you want to delete the resources. You have the patch to modify the resources in simple term. These are the most common, but you have, I think, had also as a HTTP method and copy and all other also. But these are the standard one you can use. And you have the HTTP status code like categorized from 1xx till 5xx, depend on the client error, or it's a server error, or you want to give the success thing in more precise way. So these were the overview. Let's check the advanced tooling and the design consideration for RESTful APIs. I'd like to welcome Kenichi to cover this thing.
Thank you, Ghanshyam. Hi, I'd like to explain advanced tools and design consideration for RESTful API. What are these? So first thing is API versioning. We have 2 ways for API versioning. First one is micro version. Micro version mechanism is OpenStack original, and we create this mechanism on Nova project sites, firstly. And now multiple projects are using this micro version mechanism, like ironic, cinder, manila, and so on. On this mechanism, every single API changes its version. And the RESTful API server needs to support multiple sequential versions, like range of micro versions. And API users can use their own application in long term without any changes by specify particular micro version, particular order micro version. In this case, application specify OpenStack API version compute 2.12. 2.12 is Nova micro version of Liberty release. So if you specify this micro version, your application can run on newer OpenStack like Pike release since Liberty release without any changes. This is very big advantage for existing applications. And another way is to clarify experimental API through URL. For example, Kubernetes APIs are classified into 3 levels. First one is stable, next is beta, and alpha. As you see, on stable API, URL does not contain stable or alpha keyword. And beta and alpha API, this kind of word is contained on URLs. So user can easily understand this is a beta API or alpha API or stable API. User can use stable API in long term without any changes. So this is a great thing. And server-side developer can try implementing new API as an experimenter. From the server-side developer viewpoint, it is very difficult to implement perfect API at the first stage, because as Ghanshyam said, we need to take care of many things like what is calculate status code, what is the best URL design, and what is the best format for request and response body. It is very difficult to take care of all things in a single implementation. So developer can implement a newer version as an experimenter, and they can keep improving as an experimental API. And after they consider this is a good design or good enough API, they can define this is a stable API by removing keyword beta or alpha from URL. This is a good thing. The next thing is Open API, which was called as Swagger. Open API is the world's most popular API tooling according to official site. And Open API enables development across the entire API life cycle. And Open API continue to be developed under the Open API initiative, which is hosted by Linux Foundation. And on Open API, Open API specification is a format to describe what is a RESTful API on these services. For example, in this blue diagram, URL is /resources, and this URL supports get and post on the API method. It is very easy to understand from viewpoint of human, and it is easy to understand from machine viewpoint also. And on the Open API, they have 2 approaches to implement Open API. First one is top-down approaches. In this approach, developer needs to describe Open API definition for their own RESTful API services by some tool. And next, they can generate their own server-side implementation from the definition automatically. That is a great thing. And another approach is bottom-up approaches. And on this approach, they can generate open API specific definition from server-side code implementation. But in this case, server-side application need to use some framework which support open API. And so open, as Gansham said, API document is so important. And in this way, open API document can be generated from the source code automatically. And whole OpenStack project implement 1,000 over API. And so much burden to be maintained API document by hands correctly. Now OpenStack project, Shovel, Ranger, Picasso have already implemented OpenAPI. And OpenAPI is defined as a standard document way at the OpenStack API working group. And we are QA project member in OpenStack community. And from QA project QA viewpoint, it is easy to measure API coverage by using OpenAPI. So we can just compare the API log, which shows what API is a call on the test, and the OpenAPI definition of target source code. Now I am trying to implement this kind of tool on Kubernetes community also, and most people want to do this kind of thing. So next, Gansham explain best practice for REST API, please.
Thank you, Kenichi. So let's go through the best practices and the tips for the REST APIs. Sorry. One is the great documentation. So this is the very first thing comes up. So choosing an API specification format, it provides a great advantage of developing the documentation automatically. Like as Kenichi said, OpenStack has 1,000+ APIs for all the project. So documenting it manually, it's hard. So if we had we have the correct API specification like OpenAPI, so those can be automatically generated. It makes the consistent API across different services of your cloud or of OpenStack. So with the key thing one getting started pace, that is one of the important one, because as a user, they might not know the full context. So at least having a quick start page gives them an introduction about your technology and what all things you're doing. And then explanation of every call and parameter. So no matter how well designed it is, your API design is, or it is better to save than saying sorry when it is incorrectly. So every call parameter, what your API expect, it should be clearly documented, clearly explained. HTTP response headers. So many things we accept and return as a header. So all the header your API accept has to be clearly documented. What all things are there, what all things you can mention in this, and how the operation of that API differs according to these headers. And similarly, when you return back the response from APIs, so you should explain all the headers you are returning back. All the possible error code, messages, including global concern like authentication and rate limiting. So you should have a secure API, so authentication plays an important part. And rate limiting things, obviously sorry, we don't want any cloud don't want to give the unlimited access to everyone, so there should be for multi-tenancy case, they should have some quotas thing over each tenants based on the services they offer to them. So those error message, error codes has to be documented properly, like you are not an authorized user, you are not under the authorized project you are requesting, or on rate limiting things also, like you are requesting over quotas. So it should be clearly error message mentioned in documentation. Okay, if you will do this thing, you can get this error, and what the problem is, and how to fix that. Like many times the error message is not just on the server side, it can be from the user side. So giving a troubleshooting guide or a reference to troubleshooting guide on how you can fix these error, either by modifying your request or changing the resource state by informing to admin operator. So all these information has to be there in the document. Then context-based structure. So it's like if you have multiple APIs, even I have only 20 APIs. So it's not necessary every user, everyone will start reading those from the starting in a sequential order. So every API's document should have a full context of that. So don't think that, okay, people have read this already in the starting of the first APIs, so I don't need to explain it again. No, they can start using the APIs or reading the API documentation from anywhere, any sequence. So it should have a full context in every API structure. And examples, this is one of the key thing. Not even in API documentation, any documentation or anything I want to use, if I have the example of that, it makes me to easily understand the things, how to use that. So example means URI, what request you can mention, a request example, maybe like say JSON sample example you can have. What response you return, you can have the response example there. So it makes it easy, okay, in this structural way, your API will respond all these representation of your resource. And last but not the least, keep it up to date. So we do the documentation of APIs, we keep it, and most of the developer hate documentation. So they start as APIs has to keep improving, new feature has to develop, new APIs has to come up, versioning, versioning things happens in APIs. So every time code changed, the documentation is equally important to change that. So in OpenStack, for example, case of Noah, we have for every API change, we have to have the spec things under the review. And in that spec template, I think we have an important section that whether it leads to update the documentation or not. So that controls, if I am changing any APIs in the source code, the specs or the feature will be completed only when I will complete the documentation change also. So that has to be synchronized. Otherwise, API documentation out of date and it leads to a lot of problem. So next is version your APIs, which is important for interoperability, backward compatibility, discoverability. Like user want to discover, okay, this feature is in which version. So if I have the application on cloud A, having this feature of doing the, say, live migrating your EVM, if my application, we are moving that application to cloud B, so it should be discoverable whether that feature is present there or not. So versioning things is important. So as Kenichi explained, one tooling is micro version things. You can do micro version things for every API change, how OpenStack is doing. Or you can have some other versioning mechanism which should solve all these three problems. Next, best practice for URL. So this is the complete URL path. You have a schema, then user password for authentication. That's kind of optional. You can have some token thing also in the request body. Then you have host and port, or you can have your defined path. Then path for the resources, like which resource you want to communicate. Then query you can have for the get, some filtering you want to apply, or something you want to apply on the get things, queries. So there are some tips for URL. It should be based on nouns, not verbs. consistent naming convention, like always use the plural nouns, like don't mix up that. And isolation of APIs to the data source. So for first two things, this is the one example. Like first one, if I'll have example.com/resources/resource ID, that's correct. But if I have like /resize/resource ID, so resize makes URL using a verb, so that is not easily understandable what actually this API does. The second example, yeah, always use the plural, even it is a post, creating only single resource, you just use the plural thing there. And isolation of APIs to data sources, so that is the important part. So when APIs has to interact with database or anywhere else in your system, if you are exposing those things directly, if let's say I have one get and the queries on that get APIs, and I just directly expose the database schema there, so people can query anything, even they can query the join table also, which is hard in MySQL to filtering things. So it has to be isolated. I should have a proper URL things mapped with the predefined things user can do at the API level, and make that translated, which can again interact with my DB or other anywhere else in the system. So for that, it's not completed in Noah. I'm just starting in Queens. So we are implementing the JSON schema for queries part also. So that controls to use queries incorrectly from the from the user side of view. Means they cannot mention the join table in the queries and saying give me the data. So it becomes very hard, and system returns just 500, which doesn't make sense in that. And for more readability, don't use underscore. Dash things makes more reading the URL part. Means URL should be self-explanatory and very easy to understand what this API is doing. Next, on the status code side, this is the general status you all might know. Like we use 1xx for information response, 2xx for success, then redirection you can use 3xx, then 4xx client error and server error. So we'll go through some tips on those, where to use those source code, and some practices. Like for success code, if your operation is synchronous, return 201, like say created. If it is async, use 202, accepted. Like your request is accepted and operation is being done in background. It's not completed. If it is a resource deletion synchronously, you can return 204 with no content. And second, like for exceeding the resource quota or a reservation, you should use 403 forbidden. 413 request entity too large is very close to 403, but that confusing to the user. So they don't know what request entity is large, or what should I do this request to make it pass. Should I modify the request or not? 403 forbidden, make it clear. Okay, ask your admin, do something, delete your existing things so that you can have a good amount of quota to operate the request. If it is badly formatted request, just say 4040 bad request. Don't use 422 unprocessable entity. For that, user will not know it's my mistake or it's server mistake or some admin has done something. So 400, make it clear you are requesting it badly. Change this, correct this, your request can be successful. For non-existent resources in body, status code should be 400. So this is very common mistake, actually everyone does. So if the non-existing resource is present in body, you can return the bad request. It means something you are requesting which is not correct. You can modify, it can be corrected. But if there is any resource existence, non-exist resource in URI, then 404 not found makes sense. For example, I'm saying example.com/xyz bad resource. So 404 makes sense. Means we don't find your requesting resource in URI. If I'm say requesting like example.com/server and in request body I have the volume ID. If I don't find the volume ID, which is required by your main resource in the request, I'll say this is the bad request, give me the correct volume ID in request body, then I can operate this request correctly. And yeah, if resource state is not in the stage of requested operation, then 409 conflict is the best choice instead of 400 bad request. Because this, when resource is in different state and I'm requesting something and it's not saying conflict, it makes sense like I can ask admin or someone or owner of that resource or myself to correct the state of the resource, and then my same request will be successful. 400 means the request you have to modify, then it can be successful, which cannot be done in this case because if state says the same, whatever you modify the request doesn't make it successful. And 500 internal server error, don't return this for the user errors. This is the server errors. If you return it, you are saying to user something wrong in my system. So user keep contacting operator, admin saying, okay, correct it, correct it. So for user error, never return the 500. Sorry. For best practice in method, always use the REST methods, don't customize. Like for example, post this thing, post underscore resources, say post underscore server volume. Those are customized, means those cannot be understandable by application in a standard. So don't customize, and don't use get for state change. We have some get method in OpenStack APIs who does the state change. So if you are say rebooting host, it reboot the host, change the state. Don't use get for that. Always use put or post, whatever suitable. In OpenStack, those thing has been done mistakenly, but it's API, so we cannot change that. On request and response body side, use JSON instead of XML. It's make it easy, very lightweight, simple, and in OpenStack, like Nova, Cinder, Neutron, XML was supported, but now it's removed. Only JSON thing is there. Use snake case instead of camel case. They are more readable, consistent between those. Yeah, and this is a summary for best practice. For documentation, API versioning, URL, use plural nouns always, dash in the combining nouns, status code, 200. Fewer status code is always good. If I have like all the combination of 10, 15 status code returning by one APIs and different APIs, always confusing. Avoid common mistake like we explained for 400, and this for methods and request body. So key point is keep your APIs simple and consistent. How simple they are, the best they are. Don't try to make it complex and anything. And we do have an API working group guidelines in OpenStack, which you can always refer. We keep putting our improvement and guidelines and best practices there. Yeah, I think we have short in time, 1 minute maximum. So if you guys have any question, you can always ask now, or you can reach us later also.
Yeah, I do have a question.
Yep.
You mentioned earlier that the API working group is now officially supporting the Open API. Is that something recent?
So API working group mainly is actually just a guidelines, not recommendations. So Open API is recommended by API working group. But there is a thing, if you have a large amount of existing APIs, for example, OpenStack Nova, and we tried in last cycle to use the Open API, but that is not much useful. It requires a huge amount of work. But API working group says if you are implementing a new APIs for new projects, Open API is the best thing you can start considering that.
No, the reason I'm asking is because the Open API, which is Swagger,
Yeah.
there was an issue with the micro version. It wasn't compatible.
Yes.
Yeah.
Some people are working on it, but
Yeah.
I think it's an ongoing thing.
Yeah.
It's not been resolved yet. So
Yeah, that's true.
if you support micro version, you might have an issue with Open API at the moment.
Yeah, that's still there. I think that's not
Yeah.
yet resolved. Maybe
Yeah,
you can explain.
that is a nice point. So that is a point we cannot achieve Open API on Nova side. So micro version and Action API also is an issue to implement Open API. And I propose some idea to solve this issue related to micro version, but we cannot achieve agreement to do that. Yeah, still issue is there.
Yeah.
Yeah, because I've heard that they're willing to make macro version work, but it's not yet.
Yeah, it's not
Yeah,
yet.
right.
If we solve that, like that's the best thing can be done. Yeah. So any other question? Please have. Okay, thank you very much for attending the session. Thank you, everyone.
Thank you.